Hello there, welcome to another section of the Legends Consult, and today we'll be doing a video which is one of the present topics of students, especially students writing the WASSCE and also algebra in universities and also other places. Okay, so today we'll be tackling a topic called partial functions. Partial functions, which is a subtopic of rational functions, but I want to be specific and I want to enter into the difficulties of most students. Okay, so for instance, when you have 1 over x plus 2 plus 1 over maybe x minus 1. This is two fractions adding up. And we all know that from basic algebra, when you have such a thing, it looks like this. 1 over 2 plus 1 over 3. So what you do is you find the LCM, and the LCM can be the multiples of these two numbers. So you multiply this by this, you get 6. So the LCM will be written here. Then the 6, you take this 6, you divide it by the denominator of the first fraction, which is 2. And 2 will divide, or 2 will cancel 6 3 times. So you get 3. Then you multiply the 3 that you got by the numerator, which is 1. Then you get, 3. So you write this 3 here. Then with this one to the other side, you divide the LCM by 3. So you get 2. Then you multiply it by the numerator, which is 1. Then you get what? 2. So this is it. Then you get 5 over what? 6. So this is what basically we were taught way back SHS, way back JHS, junior high school, primary school, and whatever. But this time around, we are going to I think this one too was taught in JHS. Yeah, this one too was taught in JHS. So let's use the same approach. So we find the LCM by multiplying this and this. So with the LCM is the first factor times the second one. Then what do we do next? We take the whole LCM. So x plus 2, x minus 1. Then we divide it by the first denominator, the denominator of the first fraction, which is x plus 2. So this x plus 2 will cancel the first one. We'll be left with what? X minus 1. We multiply this x minus 1 by the numerator here, which is what? 1. So we get what? X minus 1. So we write it here. Then also we do the same for the other fraction. So we take the LCM, which is x plus 2, x minus 1. We divide it by the denominator of the second fraction, which is x minus 1. When they cancel out, we'll be left with x plus 2. So we multiply it with the numerator, which is 1. Then we get x plus 2. So we write that x plus 2 here. That's what we do. We write the x plus 2 here. So having this, now we can group like terms. So since x and x are like terms, we group them x plus 2, or minus 1 plus 2 divided by the numerator, x plus 2, x minus 2. So when we add them, we'll get 2x plus 1. This, since the coefficients of the x are 1 and they are like terms, we can add their coefficients. So 1 plus 1 will give you 2. Then this one, negative 1 plus 2. Since they are like terms, they will give you 1. Then you divide by the numerator. Minus 1. Then you are good to go. So this is it. But here lies a case when they give you this and they tell you to partialize it. It means that you have to reverse it to this position again. So this is what partial functions is all about. So okay, so there are 4 types of partial functions. We have the one that has a linear factor. When we talk of a linear factor, it means that the first example I gave is a typical example of one that has a linear factor. These are factors and they are linear because the exponent of the x is 1. The highest exponent of the variables are 1. So when the highest exponent of a quadratic expression is 1, it is linear. And because they are denominators, we assume that they are the factors of the LCM. No, we don't assume, they are the factors of the LCM. So this is a typical example of a question that has a linear factor. And the other one has, the other type is when it has a repeated binomial, in the sense that maybe when the question comes with, in this form, maybe x plus 1, x plus 2 to the power 3. This part is what? A repeated binomial, or a repeated binomial. So this method too is there. So when a question comes like this, you should know how to do it. And sometimes the question can come with a quadratic factor like x plus 1 divided by x squared plus 1, x plus 2. So this is a quadratic factor. Mind you, I said that the linear factor is when the exponent is 1, and a quadratic factor is when the highest exponent is 2. Okay, so this is a linear factor, this is a quadratic factor, and this is a repeated binomial, when it has a repeated binomial in it. We all know from binomial expression that this can be expanded. This, when you have an expression like this, it can be expanded into maybe x squared plus 4x plus maybe 4. So this is the expansion of it. So when you have such a thing like this, how do you go about it? This is and the last type is the improper factor. Yeah, the improper fraction factor or improper function. So with that one, the numerator is greater than the denominator. So all the examples I'm giving, the denominators are greater than the numerator, but when there is an improper, it's like an improper fraction, 7/5. So with that one, the numerator, which is the number on top, is greater than the denominator, which is the number down. Okay, so these are the types we have. Okay, so this is a typical example of the first type, when it has a non-repeated linear function at its denominator. So this is a non-repeated linear function, and this is a non-repeated linear function. How do you go about it? So the general rule is that we say that it is equivalent to something. So what is it equivalent to? So what we do is we take the first denominator, we divide it by an alphabet. Sorry, we divide an alphabet by the first denominator. Okay, so that's what we believe. So we believe that it is equivalent to this. Then we will do the same for the second denominator. So we divide that one too by an alphabet. We divide the alphabet by the second denominator. Then what's next? Some people will tell you find the LCM. Yes, that's the right step. So you find the LCM, then you go about it. But I will tell you that that step, it's a waste of time. So the best thing you do is you maintain the numerator here. Okay, so you write it x plus 2. is equivalent to, then you multiply the A alphabet, which is the numerator of the first term, by that of the denominator of B. So you get A times X plus 2. Then you do that for B. You multiply the alphabet B by the denominator of A. So X plus 3. You are good to go. So you have skipped a whole lot of steps to be on a safer side and to be very fast. This is the best way you should do it. So when you get here, there are two methods you can use. You can use the elimination method or the substitution method. Any which way you get it right, but the best method I prefer is the elimination method. With that one, you just eliminate a variable. So even though A is a variable, X is a variable, but the variables I'm talking about is the alphabet, the one with the capital letters, the capital A and the B. So you decide which numbers will I put in the equation to give me to eliminate the variables. So you know that, okay, when X is equal to maybe -2, here will be -2 plus 2, which is what? 0. So A will be multiplying 0. So therefore A will be eliminated from the equation. So you just come 3 into brackets -2 plus 2, A -2 plus 2 plus B into brackets -2 plus 3. So here we get -6 plus 2 being equal to what? A multiplying 0, because you know that -2 plus 2 will give you what? 0. So when you get this, here becomes B into bracket -2 plus 3 will give you 1. So B times 1 will give you B. So here we get 0, right? Plus B is equal to -4. So therefore we can say that our B is equal to -4. Then we can also do the same thing for A by eliminating the B. So when you eliminate the B, you get the answer for A. So what do? We put in here -3. So when X is equal to -3, 3 into bracket -3 plus 2 is equal to A bracket -3 plus 2 plus B into bracket -3 plus 3. So all here becomes what? 0, because we've eliminated it. So since we've eliminated this, here we get -9 plus 2, which is equal to A into bracket -1. -3 plus 2 is -1, so that's what we get. So we get -7 being equal to -A. We divide here by -1, we divide here by -1, they cancel each other. So therefore our A becomes what? 7. So now we have the answer for A and B. So we've partialized this into 7 over X plus 3 plus, sorry, so there is a negative, the 4 was negative, the B was negative, so -4 over X plus 2. So this is it. Okay, so this is the type 2. With this one, it has a repeated denominator. So you can see X, you know that X starts, it is X times X. That will give you X squared. So the first denominator is X, and the second one is what? X squared. Then it goes on and on. And this one too, it starts from X minus 1. That's the first binomial. Then it goes to X minus, 1 squared. So with this, it follows the same procedure as the first one. But since the binomials are repeated, since the denominators are repeated, we give them each an alphabet, in the sense that the first alphabet, which is A, will take only X without the squared. Then the second one will take the X with the squared. Then the third one will take the first of the binomial, so it will be x minus 1, then the last one will take d, which is x minus 1 all squared. But this one is very complicated, so type 1. So you know that this is a binomial. Sorry, this is a linear factor which is not repeated. This one. So you do it the same procedure as the first one, which is a over the denominator of so x plus 2. But with the b, even though we have x plus 1 squared, we'll give it x plus 1 first, then we'll introduce a new alphabet, which is c. Then we'll give it x plus 1 squared. So this is how the repeated binomial goes like. This is how it looks like. So with that one, let's see how we do it. Because this one too, I'll show you the trick. There is a trick inside that you don't have to find the LCM, blah, blah, blah. It's a waste of time. So as usual, you maintain this one. You maintain it. So 3x squared plus x plus 1 is equivalent to a. Now what do? We multiply a by the denominator of c. The reason being that b can be found in c. So you multiply a by the denominator of c. And mind you, this works for the third type. So you multiply a by the denominator of c, you get it, you get this. Then with the b, you multiply b by its denominator and that of a. So b becomes x plus 1, x plus 2. And the c will take the denominator of a. So c becomes x plus 2. As I said, this is, you can find the LCM and you still get it right. But this is the easiest way of doing it. The first thing you do is you multiply the a by the denominator of c. That's it. Then the second thing you do is the b, you multiply it by its denominator and that of a. Then the last thing, you multiply c by the denominator of a, and you get this. So when you are here, you can still use the elimination method, you can still use the substitution method, and you still get it right. But I prefer the elimination method, so I would say where x is equal to. So this is what I'm trying to do. I'm trying to eliminate one of the variables. And when I eliminate one, it should affect the b. Any which one I want to eliminate should affect the b. For instance, if I make here -1, here will be 0, and here 2 will be 0. Do you get it? And when I make here -2, here will be 0, here also will be 0. So don't try to attempt the b, because any which one you eliminate, it affects the b. So try eliminating the a and the c and do the b later. So when you say, when x is negative, let's say -1, you know we are going to get -1 squared plus -1 plus 1. Okay, being equivalent to a into bracket -1 plus 1 all squared plus b bracket -1 plus 1 plus 1, sorry, -1 plus 2 plus c into bracket -1 plus 2. Okay, so this is what we get. So when we are here, you know that from here the calculator can do everything here, but let's try. So this will give us 3. And we know this side will be 0 because -1 plus 1 is 0. It's equal to, this will be 0. -1 plus 1 is 0. 0 squared is 0. So a into bracket 0 plus, and here will be 0. So I told you, anytime you eliminate 1, the b will be affected. So here will be 0, 1 plus c into bracket 1. So all this will be what? 0. So since they are 0, they cancel off. So we get 3 being equal to what? C. So C is equal to 3. That's the answer for C. Then we eliminate the C, because we are done eliminating what? A. So this time around we don't eliminate A, we eliminate C. So by eliminating C, we see where x is equal to -2. You know that when you put -2 here, -2 plus 2 will be what? 0. So therefore, when x is -2, let's put it inside. -2 squared plus -2 plus 1 being equal to A into brackets -2 plus 1 all squared plus B -2 plus 1 -2 plus 2 plus C into brackets -2 plus 2. Okay, so this is what we get. We know that this 2 squared is what? 4, and 4 times 3. Okay, let me do it one after the other. So here will be 4 plus minus 2 plus 1 being equal to A to brackets, here will be -1 all squared plus B. We know B will be 0 definitely, so let me not waste time there. And the C2 will be what? 0. Since we are eliminating C, B and C will be 0. So when we get here, we get 4 times 3 is 12. 12 minus 2 plus 1 is 12 minus 2 plus 1. So 12 minus 2 plus 1 is 9. 9 being equal to, this will be A. Because 1 squared is 1, and 1 times A will still be A. So 9 is equal to A. So therefore, A is equal to what? 9. This is what we get for A. Okay, so sorry, the calculation I made here was wrong. This is 12. 12 minus 2 is 10 plus 1, 11, not 9. So here 2 becomes 11. So let's do for B. So now since we are done with A and C, we can find a B. So how do we find a B? We don't eliminate anything, because when we try eliminating anything, it will affect the B. So you just put a random number inside that will not eliminate anything there. Okay, so when you put a random number like 1 inside, here will be 2, here will be 2, here will be 3, here will be 3. You can put 0, 1. 0 here, here will be 1, here will be 1, here will be 2, here will be 2. So it's a random number which will not eliminate anything there. So let's give it a try. So we are putting a random number which is 0. So where x is 0, we get 3 into bracket 0 squared plus 0 plus 1 being equal to A, which 0 plus 1 squared plus B 0 plus 1, 0 plus 2 plus C, which is 0 plus what? 2. Is it squared? Yes, squared. So this is what we get. Then we continue. We know that everything here, since this is 0, everything here is 0. So we'll be left with what? 1. Because 1 is a term on its own. So everything here will be 0, and we'll be left with 1. So 0 plus 1 is what? 1. 1 squared is 1. So A times 1 will be what? A plus B. So here will be 1. 0 plus 1 is 1. So you let me maintain it this way, otherwise someone will be confused. So 0 plus 2, 2 is 2. Then yes, 0 plus 2. So 0 plus 2 is 2, but since it is squared, you multiply it by 2, because 2 squared is 2 times itself. So 2 times 2, which is 4. So here we get 1 being equal to A, because A times 1 is A, plus 1 times 2 is 2 times B is 2b plus 2 squared, which is 4. 4 times c will give you 4c. So this is the first equation we have. So now that we have an equation and we already know the answers or the values for c and a, we just substitute them into the equation. So we will say put a, which is equal to what? 11, and c, which is equal to what? 3, into equation 1. So we substitute them. 1 being equal to 11 plus 2b plus 4c, which is 3. So we know that 1 is equal to 11 plus 4 times 3, 12, plus 2b is equal to, okay. So when we add this, we get 23 plus 2b is equal to 1. So this 23 comes to the other side of the equation and it becomes negative because here it's positive. So we get 1 minus 23 being equal to 2b, negative 22 is equal to 2b. So we divide here by 2, we divide here by 2. So therefore, b is equal to negative 11. So that's the answer for b. So you just represent it this way. The b side of the distance becomes negative. So here becomes negative 11. The a was 11. So a here 11. Then the c was 3. So positive 3. So this is the end of the first part of this series, and I hope you enjoyed it. To keep yourself abreast to my videos, you can still you can subscribe to the channel and also like the video so that other students out there will be reached. Up next is the part 2 of this series, which is partial functions. Take care. Bye bye.